Hello everyone, welcome back to CMME Made Easy, and I hope you all are doing very well. Before we begin, let me remind my dear students that the contents of this channel are only to supplement your knowledge, not to replace the regular online and offline classes in your institution. So please attend your classes and do not miss them. Also, if you like our contents, please subscribe to our YouTube channel, like the videos and share these videos with your friends, with your batchmates, with your juniors. Also, if you are a teacher, then with your students. Please follow our Facebook page and the link will be given in the description. In our last video, we discussed about the measures of central tendency, where we learned how to find a value around which the other observations in the data are concentrated. Today we shall talk about measures of dispersion. In any given data set, we shall see the values or the observations are different from each other. So how these values or observations vary or differ in the given data set, that we can learn from measures of dispersion. Whenever we look at any person or any subject, we shall see the different variables. For example, their age, blood pressure, blood sugar, serum cholesterol, etc. These values vary from person to person. So most of the time, if we randomly select 5 persons, their blood pressure, it is expected that the blood pressure will be different. So the question is, what is the normal variation? So what kind of variation we can say it is expected? So the answer to this question will be discussed in our future video when we shall talk about normal distribution. But today we shall learn how to measure the variation. Measures of central tendency do not provide information about spread or scatter of the values around them. So as I mentioned earlier, if we look at a particular data set and we see that the observations or values are different from each other, so how widely they are spread and how they are scattered in the given data set, that information can only be obtained from the measures of dispersion. Here I have given an example, the number of days of stay in hospital due to 3 diseases. So we have arbitrarily taken 3 diseases, disease A, B and C, and we have taken 5 cases of each disease. So the 5 patients suffering from disease A, they had to stay for 3 days, 4 days, 5 days, 6 days and 7 days. So these 5 patients had 5 different days of stay in the hospital because of that disease, disease A. The mean value, that means the number of stay in the hospital, is 5. So if you add them up and divide by the total number of patients, which is 5, it will be 5. And dispersion, we have basically taken the maximum number of days of stay and we have subtracted the minimum number of days of stay. So you can say this is a range. So 7 to 3, basically 4. 7 minus 3 is 4. So that is my mean and dispersion for disease A. Similarly, the mean value for disease B was 9 and dispersion was 11 minus 7, that is 4. Disease C, the mean value is also 9 and dispersion is 12. So if we look at the values here, the average number of days of stay, or you can say the mean number of days of stay of patients with disease A and B are different. So in case of disease A it is 5, in case of disease B it is 9, but the dispersion are same. So it is 4 days for both disease A and disease B. On the other hand, if you look at disease B and C, the mean or the average number of days of stay in the hospital is same for disease B and disease C, but the dispersion is not same. It is 4 days in case of disease B and 12 days in case of disease C. So as you can see, sometimes we can have the same mean but the dispersion can vary. Also sometimes we can have different means but the dispersion can be same. So just looking at the mean values, that which is the measure of central tendency, we cannot know anything about the measure of dispersion. So this is just an example to show how these two things are not always interrelated. Now, what are the different measures of dispersion? So we can have many different measures, but in today's video we shall talk about the 6 measurements of dispersion, which are range, interquartile range, also told or also mentioned as IQR, mean deviation, standard deviation denoted as HD, variance and coefficient of variation. The first measurement that we are going to talk about is the range, which is the simplest measure of dispersion. This is simplest because it is very easy to calculate the range. It is basically the difference between the highest and the lowest observation in the data. So for that we need to identify the maximum value or the maximum observation as well as the minimum value or the minimum observation in the data, and the difference between them is the range. Now as you can see, to calculate the range we only need to identify the maximum value and the minimum value. So the problem here is, from range we have no idea whatever is happening in between these two extreme values. We have only the idea about the maximum value and the minimum value, but the other values are not important while calculating the range. So if we have a range, we have no idea how the other values are dispersed. So that is why this is not of much importance. Here I have given an example. The blood pressure of 10 patients are given here. The systolic as well as diastolic blood pressures are mentioned here. So to find out the range of systolic blood pressure, we have to identify the highest systolic blood pressure. So 140, 20, 60, 40, 110, 90 like this. So maximum value is 160. Similarly, the lowest value is this one, 90. So 160 minus 90 is 70. This should be millimeter of mercury. I have forgotten to mention the unit here. So the range of systolic blood pressure is 70 millimeter of mercury. What about diastolic blood pressure? The highest one is 90, this one, and the lowest one is 60 here. So 90 minus 60 is 30 millimeter of mercury. So that is my answer for the range of systolic and diastolic blood pressure in this given example. Coming to the next one, that is the interquartile range. Interquartile range, as the name suggests, is the range of the middle 50% of the observation. So interquartile range can be mentioned as Q3 minus Q1. So this is the formula here. Now what is Q3, Q1? Let me explain all these things. What is quartile? First question, what do you mean by quartile? Because we have the name interquartile range, right? Now suppose all the values in the given data set are arranged in ascending order. That means starting from the lowest value to the highest value. Then we select 3 points in the given data set in such a way that these 3 points divide the entire data set into 4 equal parts. So as you can see, this straight line is my data set. So this is probably the lowest value and this is probably the highest value. We have identified 3 points on this data set, Q1, Q2 and Q3. These are basically first quartile, second quartile and third quartile. Now these points divide the entire data set into 4 equal parts. So 100% data, 4 equal parts means each part will be having 25% of the values or observations. Alright. So to find out the interquartile range, we have to basically get the value of Q3 and the value of Q1, and that difference is interquartile range. Now as I mentioned, we have to find out the middle 50% observations. So the first thing that we need to do is the middle 50% observation of the dataset. Now if we put a point in the center of a dataset, it divides the dataset into equal parts, 2 equal parts, each having 50%. But what is the problem here? The problem here is we have a lower 50% value and upper 50% value, right? So lower 50% observations here and upper 50% observations here. This does not give us the middle 50% observation. For that, as I mentioned earlier in this diagram, we have to find the quartiles. We need 3 quartile and we have 25% on the extreme left side, 25% on the extreme right side. In the middle we have 25%, which is basically 50% if we add them together. So Q1 to Q3, all these values comprise 50% of the whole data set. So that is why this is the middle value or middle 50%. And when we find the range of this particular portion of the data set, we get the interquartile range. So that is why we need to find out the Q3, that is the third quartile, and also the first quartile, and the difference between them is the interquartile range. Always remember, this Q2 value is basically the median value. Alright, so if we arrange the data in ascending order and find out the middlemost value, that is actually the median that we learned from the previous video where we discussed the measures of central tendency. So Q2 is always the median, then we have Q1 and Q3 on either side, and Q1 to Q3, this value is basically the middle 50% value of the whole data set, and the range of this particular portion is the interquartile range. Next one, we are going to talk about the mean deviation, which is the average of deviations of the observations from the mean value. So what do you need to do to find out the mean deviation? First, you have to calculate the mean value. So you have a given data set, that means you have certain number of observations. From that you can calculate the mean value. You already know how to calculate the mean value. Then we have to find out the deviations of observations from the mean value. So all these individual observations, they have certain values. How much smaller or bigger they are as compared to the mean value, that we have to calculate, right? Then we have to add them up. Now remember, some of them, that means some of these values will be more than the mean value, some of these values will be less than the mean value. So we can have some positive values and the negative values. If we add them up, that will actually be 0. But in this case, we shall ignore the signs. So does not matter whether the observation values are smaller or larger than the mean value. We just have to know how much deviation they have from the mean value. So we are ignoring the signs. Then we have to add them up, and then we have to divide by the total number of observations. So this is the formula for mean deviation or MD. X minus x bar divided by n. X is the value of the observation. X bar means the mean value. So x bar is always the mean. You can see you have taken the mod here. These straight lines, perpendicular straight lines means mod. That means we are ignoring the signs, positive or negative. And we have to add them up. So this is the summation sign divided by the total number of sample. Next, look at this example where we have 7 children suffering from measles, and the incubation period of all these children are given here. So 10, 9, 11, 7, 8, 9 and 9 days. So we have to find out the mean deviation of incubation period. We have made a table here. In the first column we have the incubation periods in days. So for the first child we have 10 days incubation period, second child 9 days, third child 11 days, like this. First step is to find out the mean incubation period. For that we have to add all these values, which is 63, and we have to divide it by the number of children, that is 7. So 63 divided by 7 is 9. So the mean incubation period is 9 days. This is my first step. In the second step, I have to find out the deviation of each observation from the mean value. For the first child, the value was 10. His incubation period was 10. And by calculation, the mean incubation period is 9. So the deviation is 10 minus 9, which is plus 1. Second child 9 minus 9, 0. Third child 11 minus 9 is 2. Fourth child 7, which is lower than 9. So that is why 7 minus 9 is minus 2. So like this we have the deviation of all these observations from the mean value. This is my second step. In the third step I have to add this deviation, ignoring the positive and negative signs. So if we go back to the formula, we have the mod sign here. That means we are ignoring positive or negative signs. We just want to find out how much deviated these values are from the mean value. It does not matter whether this is a smaller value or larger value as compared to the mean value. So that is why we are ignoring the plus and minus signs. We just have to add these digits, ignoring the plus and minus signs. So 1 plus 2 is 3, plus 2 is 5, plus 1 is 6. So that is why summation of x minus x bar is 6. The final step is to calculate the mean deviation using this formula, summation of x minus x bar divided by n. So summation of x minus x bar is 6, divided by n is the number of children, that is 7. So 6 by 7 is approximately 0.85. So that is why we can say the mean deviation of incubation periods in 7 children suffering from measles is 0.85 day. That is the answer. Next, we are going to talk about standard deviation, also denoted as SD. It is the most frequently used measure of dispersion, and whenever we shall talk about normal distribution in future, and not only that, during any discussion of basic as well as advanced biostatistics, we shall come across this term standard deviation multiple times. So that is why it is very important that we understand the concept of standard deviation. So standard deviation is also defined as root mean square deviation because of the formula that we shall show after few slides. It is often denoted by the Greek letter sigma, and this sigma looks like this particular sign. It is expressed in the same units as the observation. So whatever units the observations have, the standard deviation will also have the same unit. Certain important points that we should remember: if we take a sample and the observations from them and the standard deviation is measured, if we find that the standard deviation is very small, that means the values of the observation in the particular sample are very close to the mean value. On the contrary, if the standard deviation is large, that means the individual values of the observation are quite dispersed from the mean value. That means they are not very close to the mean value. Now this point A and point B may look a little bit confusing, but in the future video when we shall discuss normal distribution, this concept will be clear. Also remember, when the sample size increases, standard deviation decreases. For example, if we take a small sample and calculate the standard deviation of any particular variable, for example their age or height, whatever, and then we take another sample which is larger than the first sample, and we measure the standard deviation in that sample, we shall find that the standard deviation is smaller in case of the larger sample. If the sample size is small, the standard deviation is also increased. This can also be proved from a formula that we shall show in the next slide. So this is the formula used for standard deviation. So standard deviation is root over of the whole thing. What is this? In the numerator we have x minus x bar whole square, that is summation, divided by n. So as you can see, x minus x bar is deviation of each value from the mean. We have to square them up and then we have to take the summation divided by n, and the whole thing is put under the root over sign. If we have smaller sample size which is less than 30, so if n is less than 30, then in place of n we use n minus 1 as the denominator, and the formula looks like this. So summation of x minus x bar whole square divided by n minus 1 rather than n, and the whole thing is put under the root over sign. Now from this formula, as you can see, n or the sample size is in the denominator. So if sample size increases, so if the denominator increases, the whole value will decrease. Also if the denominator decreases, the whole value will increase. So that is why we can say standard deviation is inversely proportional to the sample size. So as I mentioned here, when the sample size increases, standard deviation decreases. Inverse is also correct. If the sample size decreases, standard deviation increases. What are the steps of calculating standard deviation? Calculate the arithmetic mean on average of the given data set. We have to find the mean value. Then you have to take the deviation of each value from the arithmetic mean. So these first two steps are exactly same as the mean deviation calculation. In the next step, we have to square each deviation. So these values we are getting, we have to square them up. After that, we have to add the squared deviations, that is the summation of x minus x bar whole square, and then divide this value by either n or n minus 1 depending on the number of sample size. If the sample size is less than 30, we use n minus 1. If it is 30 or more, then we can use n. and then the whole thing is put under the square root value. So we have to take the square root, which gives us the standard deviation. Now let me give you an example for you to understand. We have the heart rates of 12 participants, which are 58, 66, 70, 74, 80, 86, 90, 100, 79, 96, 88, 97 per minute. We have to find out the standard deviation. As you can see, we have 12 patients, so the number of observation is 12, which is less than 30. So for that, in the denominator of our formula, we have n minus 1, not n, okay, since this is less than 30. So coming to the table here that we shall have to make. Now remember, let me tell you something. Standard deviation you can calculate using any basic software, even on MS Excel, that is possible. But for a smaller sample, you can also calculate it manually. If you are a student, undergraduate or postgraduate, you may even have to calculate it manually. So for that, you need to understand, or you need to know the steps of calculating standard deviation. So first we write down the observations. So these are the heart rates of 12 different patients. Next we have to calculate the mean value or mean heart rate. For that we have to add these observations, which is 984, and divide it by the total number of patients, which is 12. So the mean heart rate is 82 per minute. Second step is we have to find out the deviation of each value or each observation from the mean value, just like the mean deviation. So 58 minus 82 is minus 24, 66 minus 82 is minus 16. So like this we have 16 deviations from the mean value. So mean is 82, and then we have the 16 observations, and for each observation we can find the deviation. Next step is not to add these values ignoring positive or negative sign. That we would have done for the mean deviation, but here we are calculating the standard deviation. So that is why you have to do another step. This step is squaring the x minus x bar value. So that is why minus 24 square is 576. Whenever we square any value, the value will always be in the positive sign. So minus when squared is always positive, and of course positive sign will be squared to positive. So after squaring each deviation, we have all these values. Next step is we have to add the summation. We have to add the individual square deviation values. So 576 plus 256 plus 144, like this. So summation of x minus x bar, which is the summation of squares of deviation, is 1914, right? So the final step is dividing 1914 by n minus 1, if you remember, because the value is less than 30, the sample size is less than 30. So n is 12, so n minus 1 will be 12 minus 1, that is 11. So 1914 divided by 11 is 174, and we have to put the whole thing under the square root. So this is the square root value, and the value is approximately 13.19. So in the given data, we can say the standard deviation of heart rate is 13.19 per minute, or you can say beats per minute, like that, because the unit will be same as the observations. So that is my answer. So now you know how to calculate the standard deviation, which is very important for your exam purpose. Also certain tests that you have to do manually, certain biostatistical test, for that you may need to calculate the standard deviation. That is also very important. The next one is the variance, which is nothing but the square of the standard deviation. So if you can calculate the standard deviation, if you square it, you will get the variance. Looking at the formula of standard deviation, we have standard deviation equal to something. So we have root over here. If we square the standard deviation, this root over sign will be gone. Similarly here also. And whatever is left in the formula, that is my variance. So that is why if you look at the formula for variance, it is summation of x minus x bar whole square divided by n if the n is more than 30. If it is less than 30, then it is summation of x minus x bar whole square divided by n minus 1. The last measure of dispersion that we are going to discuss today is the coefficient of variation. So it is used to compare relative variability of spread or variation of same character in two or more different series having different magnitude or values, or two characters in the same group. Now let me explain this part. Suppose I am taking two groups of people, so that is why two or more different series here. So two group of people, maybe one group of boys, another group of girls, and we are comparing the variation of same character. Suppose we are talking about height. This is my variable, and I am measuring the height in the two different groups, among the boys, among the girls. The height of the boys will be different from each other. That means there is some variation in heights among the boys. Similarly, there will be variation in height among the girls also. We want to know whether this variation of height among the boys is different from the variation of height among the girls. So that is why we are comparing the variation of same character, which is the height, in two or more different series. Here we have taken two groups, boys and girls. Or we can also use coefficient of variation to measure the variation of two characters in a same group. So we are not having two different groups, boys and girls, we are having a single group, but we are comparing two different variables, so two characters. Suppose we have taken a group of people, we have measured their heart rate and measured their respiratory rate. Their heart rate will be different from each other, so there is variation in heart rate among the people. Also, there will be variation in respiratory rate among those people. So we want to know whether the variation in the heart rate is different from the variation in the respiratory rate in the same group of people. So here we have a single group but two different characters. So let me summarize this thing again. We can compare two different groups for a single variable, or we can compare two different variables in a single group. Coefficient of variation is unitless. That means it does not have any unit and it is expressed in percentage. It is expressed as the ratio of standard deviation of a series to the mean of the series. The formula is coefficient of variation, standard deviation. So that means in a given data set we have to calculate the standard deviation and also we have to calculate the mean. So standard deviation divided by mean. Then we multiply the whole thing with 100 because we are expressing this as percentage. So this is the percentage here. Here I have given an example. We are supposed to compare the variability with coefficient of variation between pulse rate and respiratory rate of 100 adult males using the following information. So we have particular information here. So what we are doing here, 100 adult males. So we have one group of people. Here we do not have two different groups. We have single group of people, but we are comparing the variability of two different variables, pulse rate and respiratory rate. Now what are the information that is provided in the question? The mean and standard deviation of pulse rate per minute is 80 and 8 respectively. So mean pulse rate is 80 per minute and standard deviation is 8 per minute. Now they have not given us the pulse rate and respiratory rate separately per 100 adults. So we do not have to calculate the values. We can calculate if it is given because you already know how to calculate them. It is already given, right? So we have the mean value as well as the standard deviation. Similarly, the mean and standard deviation of respiratory rate is 25 and 4 respectively. That means mean respiratory rate is 25, standard deviation is 4. We have to compare the variability of pulse rate and respiratory rate. So we know the formula here. Coefficient of variation is SD divided by mean into 100. In case of pulse rate, the standard deviation was 8, mean was 80. So 8 divided by 80 into 100 is 10%. Similarly, the coefficient of variation for respiratory rate is 4 divided by 25 into 100 is 60%. So as you can see, the coefficient of variation of pulse rate is 10% and that of the respiratory rate is 16%. So we can say the variation is more in the respiratory rate because it is 16%. So variability of respiratory rate is more than that of the pulse rate. So in a group of 100 people, 100 male subjects, from the standard deviation and mean values of pulse rate and respiratory rate, we can mention which variable has higher variability. So in this example, respiratory rate, which is 16% variability, has more variation as compared to the pulse rate, which is 10% variability. So with this, we conclude today's session on measures of dispersion. If you like the video, please subscribe to our channel, like and share this video with your batchmates, juniors and friends from other colleges. We also have our Facebook page that you can follow. The link is given in the description. Take care and we shall see you in our next video.